Hi, welcome to another video. This is the FM radio part 2. I finally got rid of the other board, only worked when you heated it up. This is one that costs just over £5 on eBay. So this board from eBay, it's the Silicon Labs Si4703. So this is the device ID. Firmware revision is 16. I've still got it wired to my small speaker, but I can't play the radio because I'd get a copyright strike. So radios in the UK and most of Europe, I think, the FM frequency band starts at 87.5 megahertz and runs up to 108 megahertz. So abbreviated 87.5 megs. That's 87,500,000 hertz. If there was a radio station broadcasting on that frequency, 87.5, the next available channel would be in the UK and Europe. Pretty sure it's the same as Europe. The next available channel would be 87,600,000 hertz. Then 700,000 hertz, 800,000. And so this bit here is important. This is the channel spacing in the UK. So you've got to understand that to work out your channel number to get your frequency. So you've got to understand this channel spacing. In the UK and Europe, we've got 100 kilohertz channel spacing. I've got a note down here. To calculate a channel frequency with 100 kilohertz spacing, you take the channel number, multiply it by 0.1, then add the start frequency of the radio in your country. So example, so if we take a channel number of 10, if there was a radio station there, 10 times 0.1 equals 1. 1 plus 87.5, which is the start frequency in the UK, 1 plus 87.5 equals 88.5. This is a real example. So Radio 4, I only found a channel number because my radio was seeking through the channels. I'd stay listening or go and look up the frequency. So Radio 4 in South Yorkshire, it broadcasts on channel 62. So 62 multiplied by 0.1 is 6.2. 6.2 plus 87.5 equals 93.7 megahertz. That's Radio 4. Capital FM. I used to be fond of Capital FM when I lived in Surrey. So Capital FM also broadcast up here in South Yorkshire. There's actually two stations up here, one less powerful than the other. So Capital FM, channel number 176. So 176 multiplied by 0.1 is 17.6 plus 87.5 megs equals 105.1 megs. That's South Yorkshire. They do actually broadcast for East Yorkshire and East Lincolnshire, and there's a frequency up at 105.8, I believe. So that's how you calculate your frequencies. And now you can see, so that 0.1, that's 100,000 hertz. 105 million and 100,000 hertz, so 105.1 megahertz. So here's a quick look at the radio registers. There are 16 registers and each register has got 16 bits. I'm using i2C to communicate today, specifically Microelectronica's software controlled i2C, because the particular PIC I'm using, there's a glitch with the i2C, it doesn't issue a stop command. If I show you some code first, when communicating with the device, although the chip manufacturers say the address is 10, that excludes the read and write bit. So the actual address to write to the chip is hexadecimal 20, and to read from it, you just make the read-write bit a 1. So to write, it's a 20, to read, 21. Normally, you would use a start address for the device, then you would use a register address. Which register do you want to write to? But on this chip, you don't get a choice of what register you want to write to. When you write to the device, it automatically starts at register 2. It writes to 2, then the next bit of information you write is 3, 4, 5, up to 15. To turn on the oscillator, that's one of the first things you have to do. That's up at register 7. I'll put the C file on GitHub and put a link in the show more. So this is my main. These bits reset the radio. You can see I initialize Microelectronica's software controlled i2C. So I just want to turn on the oscillator. So I write the address of the chip. Remember, it starts at register 2, then 3, then 4. You can see I'm writing nothing. 5, 6. Finally, we get down to register 7. Well, have a look at the datasheet. To turn the crystal on, the oscillator bit is bit 7. Now, what's slightly confusing is all these registers. Remember, I said there's 16 bits per register. I'm just using 8-bit I2C. So we write the upper 8 bits, then the lower 8 bits. So it's all in the datasheet, but so to turn the oscillator on, we set the uppermost bit, which is bit 7, turn that bit on, then nothing, 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 and then the last bit of the up byte we set as 1. So remember, counting backwards, 7, 6, 5, 4, 3, 2, 1, 0. So the upper byte is hexadecimal 81, which, if you remember from the programmer view on a calculator, hexadecimal 81 is bit 7 there and bit 0. So 7, 6, 5, 4, 3, 2, 1, 0. Turning on bit 7 and bit 0. That just turns on the oscillator, and because sometimes the oscillator didn't start, I simply write that twice. Have a look at the code, it will all make sense. The datasheet says you need a delay of 500 milliseconds after you start the oscillator. So after that, I then have this function to tune. When I've defined my variables, I've got this channel set, 145. So 145 is actually Greatest Hits Radio FM. Channel 145 multiplied by 0.1 equals 14.5 plus 87.5 equals frequency 102 megahertz. If we go to my tune, as I say, the C file is going to be in the show more. So I'm writing to the chip, that's the address 20. I'm disabling the mute. Have a quick look at the registers again. So register 2, I'm disabling the mute, and the last bit of the lower byte is the enable, so enabling the chip, turning it on. So bit 14 and bit 0, hexadecimal 40 and bit 0 of the lower byte. I'm turning on the tune bit, which is the next register, register 3, tune, and then I'm putting in the channel number in the lower byte of register 3. So turning on the tune, and that's the channel 145. Have a look at the datasheet. These are a couple of RDS bits, nothing in the lower byte. 28 of, this is register 5. If I show you register 5, so I'm writing a 28 in here. This is a seek signal strength. So if you put a 0, it will find all the weak stations. I've got a 28, and that skips all the weak stations. But then this spacing, channel spacing, this is the important part. Have a look at the datasheet. For UK and Europe, the spacing has to be set to 0, 1, which gives you 100 kilohertz spacing. And then the last 4 bits, 3 to 0, so 3, 2, 1, 0, 4 bits, that's the volume. But so don't think you've got a small volume range, it's a logarithmic scale. So just a change of 1 digit causes a big change in volume. And that's the last register I'm writing to there. So 28 for received signal strength. 5 and 4 and 0, 1 gives you the 100 kilohertz spacing, and I've just got my volume on 4. So I think I'll leave it there. Have a look at the C file. It's a shame I can't demonstrate this because it works really well. There's other issues I could go into. I could be here all night, and most of it will make no sense, not unless you've had experience with the radios. When the radio automatically tunes, when it's finished finding a channel, this STC bit, seek complete, gets set. And you can see by decimal 64, it's bit 6 of a register. The radio will not seek and find another station until this bit is cleared. To clear this bit, you have to clear the tune bit, which you saw was bit 7 of another register. So to clear this, you clear the tune, then this gets cleared, then the seek will automatically find another station. So have a look at the C file. There's essentially a counter in a while 1. It counts to 60. When it gets to 60, it sets the tune bits. Only when those tune bits are set, or the seek bits, does my function clear the STC bit. That's nice for demonstration purposes because it means I've got 2 minutes to demonstrate this display instead of 1 minute. If you enable the RDS, you've got to have a strong signal strength, otherwise the RDS won't come through. Anyway, have a look at the C file. It's in the Show More. If you want to take the C file and want to make a donation, there's also a link in the Show More. Hopefully it's given you an insight into FM radios and the Silicon Labs Si4703. The C file, as you receive it, will be doing this. It will be seeking for a new channel every minute or two. If you find a channel you like, just program that one channel number in one of the variables that I showed you earlier. So the radio is actually straightforward to get going. I'm impressed. Hopefully you found this informative. Thanks for watching.